Assalamu alaikum, dear students. Today our topic is instantaneous rate of reaction, and afterwards we will also discuss what are the factors affecting the rates of chemical reactions. First, what is instantaneous rate of reaction? In order to know the rate of reaction at any instant during the course of the reaction, instantaneous rate of reaction has been introduced. तो अगर हम किसी इंस्टेंट पे रेट ऑफ रिएक्शन कैलकुलेट करने जा रहे हैं तो उस वक्त के रेट ऑफ रिएक्शन को इंस्टेंटेनियस रेट ऑफ रिएक्शन कहते हैं. इट मे बी इट इज डिफाइंड एज rate of change of concentration of any one of the reactants or products at that instant of time. So this instantaneous rate of reaction is just like the average rate of reaction जो हमने last lecture में discuss किया. But the only difference is in the average rate of reaction we calculate the rate of reaction at a definite time interval. Here we calculate the change in the concentration of the reactant or product at a particular instant of the time. So it may also be defined as it may also be defined as the rate of as the average rate of reaction at smallest time interval, say dt, i.e. when del t approaches to 0. तो ये हम ऐसे भी डिफाइन कर सकते हैं कि ये एवरेज रेट ऑफ रिएक्शन है फॉर ए स्मॉलेस्ट टाइम इंटरवल. जिस तरह हम टाइम इंटरवल एक डेफिनेट टाइम इंटरवल इन केस ऑफ द एवरेज रेट ऑफ रिएक्शन बिटवीन T1 एंड T2, तो ये T1 minus T2 that is the time interval in this average of rate of reaction in this instantaneous rate of reaction is the smallest. That means we say that del T approaches 0 in case of the instantaneous rate of reaction. Or this we can also this the average we can say average rate of reaction is equal to instantaneous rate if time interval del t is very small or approaches zero. So this is how we can define this instantaneous rate of reaction. लेकिन आपको अंडरस्टैंड करने के लिए मैं just I will draw a graph, or let us take the change in concentration of the reactant. हम concentration change in concentration of reactant भी इसको define करने के लिए ले सकते हैं और change in concentration of the product भी ले सकते हैं. Let us take the change in concentration of the reactant just in case of the average rate of reaction. So when we plot, it is like this. Change in concentration, this is concentration. तो ये time period है. तो अगर जैसे हमने average rate of reaction हम निकालते हैं between a specific time period, between 5 and 10 minutes or 10 or 15 minutes or 15 and 20 minutes. So the change in the concentration divided by this time period will give us the average rate of reaction. लेकिन यहाँ पर क्या हम करते हैं? It is the rate of reaction at an instant of time. Instant of time means suppose time is equal to 10 minutes. So at 10 minutes we can calculate, we have to calculate the rate of reaction, and that rate of reaction will give us the instantaneous rate of reaction. So these are the three definitions of the instantaneous rate of reaction. So if we have, if the change in the concentration is very small, that is dx, and change in the time is very small, that is dt, then instantaneous rate of reaction is, or instantaneous is equal to dx divided by dt. Or for a reaction, or gives product, or gives, this is the reactant, it gives the product. For this we write the instantaneous rate equal to, it is dr divided by dt. It is reactant, so this is decrease in the concentration of the reactant, or this is dp divided by dt. This is plus because the concentration of the product increases as the time passes. So here we use, instead of del is used for the larger change and d is used for the smallest change. If we have the smallest change in the concentration of the reactant, that is decrease in the concentration of the reactant divided by very small time period, it is the smallest time period, or we can say that the del T in case of the average rate of reaction that approaches to zero, that is not zero but that approaches to zero. So for this smallest time period, or it is equal to change in the concentration of the product, very small change in the concentration of the product divided by the dt, which is the small time period. तो ये क्लियर करने के लिए ज़्यादा आपको इस तरह से क्लियर हो जाए, if we calculate the instantaneous rate of reaction by plotting the graph. So calculation of the instantaneous rate of reaction. Calculation of instantaneous rate of reaction. In order to calculate the instantaneous rate of reaction, it tangent is drawn to the graph which is obtained by plotting the concentration of the reactant versus the time, or the concentration of the product versus the time. And the tangent is drawn to the curve at a point which corresponds the time at which we have to calculate the rate of reaction, that is the instantaneous rate of reaction, and the slope of the tangent will determine the instantaneous rate of reaction. So, when we plot the graph between the change in the concentration of the reactant and the time, this is concentration of a reactant this is time. Or we can plot it between the change in the concentration of the product this is time, and during the course of the reaction the concentration of the reactant decreases as the reaction proceeds, and the concentration of the product increases as the reaction progresses. Now, suppose at time t is equal to 10 minutes, we have to calculate the instantaneous rate of reaction. So, the point which corresponds to the time 10 minutes is P. At P, we will draw a tangent to the curve that is obtained by plotting the concentration versus the time. This is the tangent which we have drawn, and the slope of the tangent determines the rate of the reaction. Now slope, we will draw the slope. Say this is the small change in the concentration, and we denote it by dx, and this is the small change in the time, we denote it by dt. Then the instantaneous rate is equal to minus slope. In case of the reactant, this is equal to the minus slope. How we can calculate the slope? Slope, as in the mathematics, it is equal to the tangent of that theta, and if you will see, this is the perpendicular and this is the base. This is dx, the small change in the concentration, that is dx, and time is t dt. So at time 10 minutes, we have the small change in the concentration, that is dx. We have small change in the time, that is dt, but it is the reactant, so we write minus dx by dt. It will give us the instantaneous rate of reaction. Similarly, if we have to calculate it for the product, say at t is equal to 10, this is the point which corresponds to the time where we have to calculate the rate of reaction. So at this point we draw a tangent to the curve, and the slope of the tangent will determine the rate of reaction. This is dx, this is the concentration, and this is the time, this is dt. So here we write instantaneous is equal to dx by dt, because this is the product. Here we have to write this as positive sign. And another way to calculate this is that we produce the tangent so that it intersects the interceptors at, say, this is L and this is M. So this is the origin, and what is concentration interceptors in terms of the y on y-axis, that is OL. This is OL, that is the perpendicular, and this is OM, that is the base. The OL and divide by OM with minus sign will give us the slope, and this will be also instantaneous rate of reaction. So whether we will calculate by this method or by this method or by this taking the product, in all the cases we will get the same result for the instantaneous rate of reaction. Now after this we will take what are the factors which affect the rates of chemical reactions. Factors affecting rates of chemical reactions. Chemical reactions are affected by a number of the factors. We will write all of these one by one and discuss them. Number one is nature of the reactants. The nature of the reactants affect the rates of the chemical reactions. To understand this, let's take two reactions, NO plus O2 gives NO2. CO plus O2 gives CO2. The two reactions appear to be similar. अगर आप देखो कि this is nitric oxide, it is combustion forms nitrogen dioxide, carbon monoxide upon reaction with the oxygen forms carbon dioxide. The combustion of in the first reaction, the combustion of the nitric oxide is fast as compared to that of the combustion of the carbon monoxide. That means the first reaction is fast and the second reaction is slow. This is because that different energies are required to different amount of energies are required to break different energies are required to break different bonds, that is bonds on the reactant side, and different energies are required for breaking different bonds, and different energies are released in forming different bonds, that is the bonds on the products. Actually क्या होता है, when the reactants react, we have to apply the energy or they required energy to break the bond. Here in the first reaction there is a bond between nitrogen and oxygen and the oxygen, and while forming the product these bonds break and the new bonds, that is oxygen, nitrogen, oxygen, is formed in case of the first reaction. So different energy are required to break the bonds of the reactants, and different energies are released in forming the bonds of the products. So the nature of the reactants affect the rates of the chemical reactions. This was first, and number second. Concentration of the reactants. The rate of the reaction depends upon the concentration of the reactants, and it is maximum to start with. It is maximum to start with and decreases with decrease in the concentration. क्योंकि रेट ऑफ रिएक्शन जो है वो डिपेंड करती है, डिपेंड्स, रेट इज प्रोपोर्शनल टू द कंसंट्रेशन. तो ये रेट ऑफ रिएक्शन जो होती है ये उस वक्त सबसे मैक्सिमम होती है जब हम रिएक्शन स्टार्ट करते हैं, और एज द रिएक्शन प्रोसीड्स द progresses, the concentration, the rate decreases because the concentration of the reactant also decreases. Thus, greater the concentration of a reactant, faster is the reaction. as the concentration decreases, as the concentration of reactant decreases, rate of reaction also decreases. This was the second factor, that is concentration of the reactant. Now the third is temperature. Number third is temperature. Increase in the temperature increases the rate of the chemical reactions. What happens actually? Actually, the energy of the reactants increase with increase in temperature. And so will be the number of collisions. क्या होता है जब हम किसी रिएक्शन में टेम्परेचर इंक्रीज करते हैं, दैट मीन्स वी आर अप्लाइंग द हीट, तो एनर्जी टेम्परेचर इंक्रीज होने से द एनर्जी ऑफ द रिएक्टेंट्स इंक्रीजेस, एंड when it increases the number of the collisions also increase. When the number of the collisions increase, the rate of reaction also increases, the reaction becomes faster. So when the rate of reaction also increases, so it has been observed that in most reactions the rate of reaction becomes almost double for every 10-degree rise in temperature. कि मोस्ट ऑफ द रिएक्शन में जो होता है, मोस्ट ऑफ द केसेस में क्या होता है कि रेट ऑफ रिएक्शन डबल होती है हर 10 डिग्री राइज इन टेम्परेचर के साथ. एंड very important, it is very important that the effect of this temperature is independent of the concentration of the reactants. चाहे concentration reactants की कितनी हो तब भी, चाहे कम हो ज़्यादा हो, but the temperature has its effect. Every 10 degree rise in temperature almost doubles the rate of chemical reaction. Now the fourth one is What is a catalyst? A catalyst generally increases the speed of the reaction without itself being consumed in the reaction or getting or without itself undergoing any chemical change. तो कैटलिस्ट का काम क्या है? It generally enhances, increases the speed of the reaction without undergoing any chemical change during the chemical reaction. तो क्या देखा गया है? It has been observed that in many reactions the presence of the catalyst increases the speed of the reaction. For example, the reaction between hydrogen and oxygen. The mixture of hydrogen and oxygen do not react at room temperature. But in presence of catalyst, like finely divided platinum, the reaction occurs quite vigorously. So, if we use the catalyst, there are many reactions which enhance the rate of the chemical reaction. यहाँ हम सिंपल रिएक्शन हाइड्रोजन और ऑक्सीजन रूम टेम्परेचर पे नहीं रिएक्ट करते हैं, लेकिन कैटलिस्ट के होते हुए जैसे कि फाइनली डिवाइडेड प्लेटिनम हम ले लें तो दे रिएक्ट वेरी विगरसली एंड फॉर्म द प्रोडक्ट. दिस इज द इफेक्ट ऑफ द कैटलिस्ट ऑन the rate of chemical reaction. Next is exposure to radiation. In some reactions, the rate is considerably increased by the presence of certain radiations. The photon of these radiations possess sufficient energy to break the bonds of the reactants to form the product. तो कुछ बहुत सारी रिएक्शन ऐसे हैं जो बहुत स्लो चलती है या वो दे डू नॉट टेक प्लेस, लेकिन जब हम वो रिएक्शंस इन प्रेजेंट ऑफ द रेडिएशन लेते हैं द रिएक्शन टेक प्लेस वेरी क्विकली. फॉर एग्जाम्पल तो क्या होता है, द फोटोन ऑफ दीज रेडिएशन, ये जो रेडिएशन हम उन पे डालते हैं उनमें उतनी एनर्जी होती है उनके फोटोन में विच हैज फ्रीक्वेंसी E एंड एनर्जी h nu. E is equal to h nu. They have the energy which is sufficient. These radiations have the energy which is sufficient to break the bonds of the reactants and form the product. For example, the reaction between the hydrogen and the chlorine, it is very slow in absence of the light, but in presence of the light the reaction takes place very quickly and form the ICl gas. Therefore, this on exposure to radiation, some radiations increase, enhance the rates of some of the chemical reactions. Now, the last is surface area of the reactants. In case of solid reactants, smaller the particle size, greater is the surface area. Which provide more opportunity for reactants to come in contact or collide to form the product. In case of the solid reactant, smaller the particle size, जितना particle size reactant का smaller होगा, surface area उनकी ज़्यादा होगी, that they will come in contact with each other. ज़्यादा से ज़्यादा contacts होंगे between the reactant molecules and they will collide to form the reactant and product, and the reaction will be faster. The rate of reaction will be faster as compared अगर हम reactants ऐसे ले लेंगे जिनका particle size जो है वो बड़ा होगा, बड़ा होने से जो surface area जो उनका होगा, जो contacts होंगे वो कम होंगे between the particles of the reactants. Naturally वो जो है rate of reaction जो है वो slow होगी as compared to that when the particle size is smaller and greater surface area between for the reactant molecules to contact or to collide with each other. So this was all about the effect of factors affecting the rates of chemical reactions. Thank you.